calculate the support reactions at A, B, and D. This is a frame example which is made up of two segments. A to C is one segment and C to D is another segment because there is a pin in here. Therefore, we need to draw FBD for each segment and find support reactions or unknown forces for each segment. I start with CD because I will end up having less unknowns by drawing FBD for the segment. So FBD for segment CD. I have dy here, I have cy in here, and I'm going to have cx in here. And externally, I have a force that acts. I replace this distributed force with one point force, and that's equal to 6 times 10, because this is the segment we are looking for. 6 times 10, and it's equal to 60. Now, because there is no horizontal force, if I write sigma f x is 0, that means that cx is 0. Now, by looking at this free body diagram, you see that there is a 60 kip force in the middle of this beam. So 5 feet, 5 feet. It's a common sense just to say that cy is equal to dy and it's equal half of 60, which means 30 kip. But if you don't know that, you just have to follow the procedures that we have and just, for example, take sigma m above d is 0. From there, assuming that this is my positive direction, it's going to be cy times 10 feet minus 60 times 5 feet is 0. From there, cy is going to be 60 times 5 divided to 10, and that's going to be 30 kip. Then, by writing sigma fy is 0, you can say that dy is equal to 30 as well. So this is the way that you can solve it, or if you just look at it, it's common sense to say that it's divided into two supports. Now I have to go to the next segment, which is ABC, and I need to draw free body diagram for it, and again use equations of equilibrium to find the unknown support reactions in here. You notice that I wrote I replaced this distributed force for CD, and I need to replace the distributed force in this segment with another point force for ABC. Okay, that's how we solve it. So this is going to be by, and also I calculated this dy. I have to replace it with the opposite direction. Dy was 30. It was upwards on the left side of sorry, it's cy. So it was upwards in the left side. That means that it should be downwards on the right side so that they cancel each other. So cy is downwards in here. Okay, I calculated cy upwards on the right side, which was 30. Therefore, for this segment, it's going to be downwards, and this is how they cancel each other. So 30, and I have this distributed force replaced with a point force, and that's going to be 6 times the distance is 30. That means 180, and it's acting 15 feet from here, 15 feet from there. And that's it. Now I can take moment about A or C to find A or B to find one of the unknowns. So I take moment about B. It's about A. Sorry, it is easy. Sigma m about A is 0. From there, I'm assuming that this is my positive direction. Therefore, starting from the right, negative 30 times 30. The distance is also 30. This is 20 and this is 10. Because it's acting in the opposite direction, therefore it's negative 30 times 30 plus by times 20 minus 180 times 15 is equal to 0. From there, you can calculate by. It's going to be 1 over 20 times, this one is 900 and the other one is 2700. 180 times 15 is 2700. And that's going to be 180 kips. So I calculated by, and by writing sigma fy is 0, I can find ay, which is going to be 180. So I'm writing in this way. So positive 180 minus 180 plus 180, which I calculated in here, and minus 30, it's going to be 0. From there, ay is positive 30 kip. And that's how you find all the unknown